Hi, this is a little video on how to use the quadratic formula. Someone took the equation, a quadratic equation in standard form, and used the completing the square process on it to solve for x. And instead of numbers, they used a, b, and c to represent the coefficient for the squared term, the coefficient for the middle term, and the coefficient of the constant, or the number that the constant is. They use that a, b, and c. They just use the letters and solve for x and got a formula where all you have to do is get the equation in standard form, identify a, b, and c, plug in the values for a, b, and c into this formula, and simplify to solve for x. So these are the steps. So the first thing you want to do, we're going to solve this equation. It is a quadratic equation. It has an x squared term. We want to get it into standard form. So I need to subtract 2x from both sides and 3 from both sides and get it set equal to 0. So on the left, I have a 3x squared, and I'm going to minus 2x from both sides, minus 3 from both sides, and leave a 0 on the right. So now we're in standard form. So I can identify the a, the b, and the c. Got to be very careful with this and pay attention to your negative values. In this, a is positive 3 right here. The b is negative 2, which is the coefficient of the middle term of the x to the first term. So b is negative 2, and c is negative 3. Okay, so now we can get the answer or answers to this quadratic equation by substituting these numbers in for a. A is going to go here and here, B is going to go here and here, C is going to go here. This 4 is hard-coded, it's part of the formula, and so is the 2. So we write x equals, and I always put all negative values in parentheses when I'm doing this, the opposite of b, because b might be a negative number, which it is here. So the opposite of b, which is negative 2, plus or minus, I'm just following this, the square root of b squared. So this is negative 2, which is b squared, minus 4, just writing this out, and I'm going to leave parentheses for a times c. A is 3, and c is negative 3. So negatives are where people make the most mistakes with this. And this is all over, the entire right side is over 2 times a, and a is 3. Okay, and then we just simplify this down. So the first thing to do usually is to simplify under the square root sign. So I'm just going to jot down my computations up here above. Negative 2, when I square it, multiply it by itself, is positive 4. Minus 4 times 3 times negative 3. So minus a negative 4 times 3 is 12, times 3 is 36. So it's minus a negative 36, which is plus 36. So this whole thing is going to reduce down to the value of 4 plus 36, which is 40. So I go to the next line, and I'm continuing to simplify. The opposite of negative 2 is just a positive 2, plus or minus the square root of, we said this is 40 under the radical sign, under the square root sign, and that is all over the entire right side over 2 times 3, which is 6. So now I have to simplify the square root of 40. If you think about prime factors, divide by 2 as long as you can. This is 2 times 20. 20 is 2 times 10, and 10 is 2 times 5. So I have a pair of 2's there. So a 2 will come out of the radical, and 2 times 5, or 10, will stay in. Okay, so 2 root 10. So it's going to be 2 plus or minus 2 times the square root of 10 all over 6. Okay, so the first thing that we did was simplify the radical. After we've simplified the radical, we look at, can we reduce this fraction? And you can if there is a greatest common factor in all 3 of these. It has to be in all 3. both places here in the numerator, both the rational part of this value, the rational 2 out here, this 2, and the 6. Under the radical, the square root of 10 is not a 10, and we ignore it. There's nothing that that's going to reduce by. So in this, because these all divide or have a common factor of 2, we can divide each of these by 2, dividing the whole numerator by 2 and the whole denominator by 2. Think of it like this. If I factor the numerator and I factor the 2 out to the front, the greatest common factor of 2, I'm left with 1 plus or minus 1 times the square root of 10 in the numerator. And I can think of 6 as 2 times 3. And these two, the 2 over 2 is a 1, and that cancels. So I get 1 plus or minus, and this 1 can be invisible. So I get 1 plus or minus square root of 10 all over 3. And that represents two solutions. 1 plus the square root of 10 over 3, and 1 minus the square root of 10 all over 3. Okay, and these values can be estimated as decimals using your calculator. Again, an easier way, if you don't need to factor it out, is to just see that there's a common 2, and you're thinking of like, I'm going to divide this whole thing by a big fat 1 in the form of 2 over 2. And that's how you get a 3 in your denominator and a 1 plus 1 here, 1 plus invisible 1 times the square root of 10, oops, plus or minus. So anyway, that's quadratic formula. Put it in standard form, the quadratic equation, identify A, B, and C, substitute the numbers that represent A, B, and C into this formula, and simplify. Simplify the radical under the radical first, and then see if you can reduce the fraction that's left. Remember, you have to have all three, this little triangle here, a common factor in all of those to continue to simplify. Alrighty, so that is it. Good luck.